So now you know that this volume is actually a bunch of voxels. And file structure-wise, the way it's saved is in the form of multiple slices. So you have a lot of 2D slices stacked on top of each other to create the 3D information. And this is why oftentimes the CT scans are referred to as tip stacks. Now let's take a look at one of those slices. And I would like you to take a moment and look at this image and think about what you see. When we analyze images like those, we use computers. But think about this process is we humans in those computers or machines or robots, however you call them, we don't look at this image the same way. What we see in this image is something like, okay, I see 1, 2, 3, 4, maybe 5 phases. And we can do this very easily. And knowing that this is a geological sample, some of you even could tell which phase is what. But what about those computers? When they look at the same image, what goes through their mind, if they have one, is more like this. So the question is, how are we going to work together? We have to find some sort of common language between us. And computers might ask, do you speak binary? Well, we don't. At least most of us don't. But what about numbers? They can understand numbers. What about histograms? Well, they know histograms too. So this is a good place to start. Maybe we can use histograms as the common language. Now, what is a histogram? So let's take a look at this slice again. And we're going to zoom into this image until you see the individual pixels. Then you can take the gray level as your x-axis and the number of pixels for each gray level as your y-axis. And you're going to check those pixels one by one. This one, for example, is 3241. So you put a little box in the graph. This one is 3536, and you just keep going. You're going to check all those pixels. And eventually, you plot all those gray levels in the same graph. And this is a histogram of this original image. And then when you look at this histogram, you realize that there are 2 peaks. One is for the dark pixels and the one for the lighter pixels. And this means that you can simply set a threshold between those 2 peaks and say that all those pixels on the left side belong to phase A, those dark pixels, phase A, and you map them back to the original image. You can do the same thing for the lighter gray pixels, phase B, and you map them back to the original image. And this is how you can segment this image into 2 different phases. So you can see how handy a histogram can come in when you're trying to segment different images into different phases. Now, let's zoom out to see the big picture. So this sample has 5 phases. By the way, this peak is coming from the air outside of the sample. Now, for those 5 phases, you can set multiple thresholds for phase 1, 2, 3, 4, 5, and map all those pixels back to the original image. Now, you just segmented this image into 5 different phases. And this is just one cross-section or slice, but you can do this for the entire volume to segment this volume into 5 different phases. And at this point, you can calculate volume percentage, for example. And percentage calculation is probably the most commonly done quantitative analysis by X-ray CT.